Welcome back. You're watching Centerline Designs. My name's Cole, and today we are finally getting back to the Snowcat build. Oh, I'm so excited. It's been a long time, haven't worked on it in quite a while. You know, sometimes life throws you curveballs, but doesn't matter. We're getting at it today, and I am going to be pretty excited to show you what we're doing. We're going to template the back of the engine. We need to create a plate that will mount all the bracketry to hold the pump assembly on for the hydraulics. And we're going to template the back of the engine. I'm going to take you through some design using CAD, Fusion 360. I'm going to process that all the way through to the CNC table, get a cutout part, and test fit it. So it's going to be a pretty cool thing. I haven't quite done this start to finish, this process before, so I'm probably going to be learning with me, but let's get in the shop, enough talking, and check it out. All right, I'm just going to walk you through what I was talking about outside there quickly. So this is the face that the transmission normally mounts to. The engine is transverse in the car, which means it's, you know, perpendicular to the direction of the car. But anyways, that doesn't matter so much. This is the surface that we need to template. I want to mark out all these bolt holes and the center of the crankshaft so that I can cut a big relief circle to go over the flywheel and clear it. And then we have two dowel points down here and down here. I need to get marked out so when we take it off and put it back on, it's located. It can't move anywhere. And then off of here, we're going to have a bracket that comes out 8 to 10 inches. I really haven't determined how long it needs to be yet. And then that's going to provide the rear mount of the engine to the frame. Right now we have a front engine mount in, but we have nothing supporting the back. I was going to go a slightly different route with this, but I changed my mind. These are coming off and we're doing it a little bit differently. And then inside here, we'll have a shaft that's shouldered and bolted to the flywheel. And then we have a large magnetic clutch, and that's going to allow us to have a neutral position. So the engine can be running, but the hydraulics will not be live. And that's really critical for me because if we're out ice fishing and you got to throw the kids in here and warm them up or something like that, I don't want the machine to be able to drive, so we can kill that. And then it's not hazardous to have kids rolling around in there or anything. And then behind that, there'll be another little shaft and then our tandem piston pump assembly. And that's all going to be supported off of this like bell housing bracket that we're going to make here. But first things first is we got to get some paper together. I'm going to lay it on here. We're going to mark out every hole. And then I'll take you through the process of running that through CAD and creating a CNC file. And I don't really know how far I'm going to get today. I'm definitely not going to get the whole bracket built, but we'll get started. Getting started is often the hardest part. So that being said, let's go get the paper together. Okay, so I know rough dimensions here need to be approximately 15 inches wide. So I don't have any larger paper. So we're going to do this with 8.5 by 11. Tape this together, and then I'll figure out the actual shape and everything when it's on there. This is just a starting point. So 15. Let's do it again. All right, that is the rough perimeter of what this bracket will be. Pretty confident in it working out all right. Okay, let's go get that mounted. All right, I will try to video this as best as I can, but it's not the easiest place to work. So how are we gonna do this? Okay. Well, I didn't really account for the depth the crank sits out, which means my paper template isn't going to sit flat. You know, this is kind of what you do if you're making a gasket for something. You can lay your gasket material on or a template, and then you take a little ball peen hammer, and you can kind of just gently tap around the holes, and it will mark all the holes on here really well for you. But I do have another idea. I am going to try and just take a picture of this nice and square. And then I'm going to run it into the computer and give it some dimensions, and we'll see how that works. I might actually be able to skip this step, come to think about it. So, all right, let's try that. Ugh. Okay, now that I got Fusion 360 opened up and saved, we need to insert that image I took of the back of the engine, and it is called Bringing in a Canvas. I'm going to find it in my computer here. I have a cropped version from fairly far back. I took some close-up ones, but there's a bit of an angle from the camera to some of the holes, so they would look not as centered. So I went back fairly far, and then I cropped it up close, and I can get a better, more accurate view of all these holes. So let's just open that up. And I want to place it, because this is going to become a CNC file, I want to place it on my XY with Z coming out. And just to roughly line this up, let's put the crank approximately near the origin. I'm going to click OK. So now you can see we have a pretty accurate view of a lot of these holes. And the next thing to do will be to start a sketch. We'll start a sketch, and then we can start laying out some of these critical holes that we need. And then what we need to do is scale this image to the back of the engine. And in order to do that, I'm going to have to pick 2 reference points somewhere on here. I have to decide where I want to go. It could be from hole edge to hole edge, or from bolt to bolt, or potentially even just the diameter of this inner circle of the crank. But find something that is easy to measure on the engine. I'll find some marks. What I guess I should really do is put some scribe marks in here. Yeah, you know what? I think I'm going to redo this. I'm going to put a couple scribe marks on the engine at a known distance apart, say here and here. I'll do it to an even number, and then I can come in and pick that scribe point and set a scale to it, and this entire image then will come to scale. And then I'll go and verify hole-to-hole measurements and things like that. And then I can draw the outline of what I want this to look like. I can put in circles, and then we're going to turn this into a CNC cut file for the plasma table. But let me go get some marks on this engine. I'll bring a new image in, and we'll try that. That's probably the best thing to do rather than just trying to find points. So I'll get that done, and we'll meet you back here. All right. Like I say, I've never done this before. I have researched it, but you know, it's one thing to watch it been done and do it yourself. So you know, we're kind of learning this together. I thought I could go with that paper template, ran into some issues. I took the image, and I think that's going to work really well, but I think to make it work the best, I need to give myself 2 reference points to scale the image to. If I try to go off holes or different things like that, I might introduce a little error. I think this will be the best way. So I'm going to go ahead and just prick a little hole there. And then let's do a set, say 3 inches. So dial this into 3. Now I know this isn't going to be really the most precise method, but I think it's going to get us really close. You know, I'm going to oversize the bolt holes anyways. The only thing that's going to matter that I'm going to have to ream out or find a way of doing after is doweling. I'll probably undersize these holes and drill them out and ream them to the size I want, even if it means oversizing the holes in the block already. So I'm pretty sure we can work around that, but let's try doing this now. So I got that set to 3. Okay, there's my mark. Let's prick that. There. I should be able to find these 2 marks in the image, and they are set to you know, I'm not really worried about 5 or 10 thou here. Nothing about this is that precise, right? So, but I think it's a really good starting point. All right, let's load that in the computer and see what that does for us. Okay, this is the new image in here. Now, I know it looks like it's hard to see, but if we zoom in, there is my one punch mark right there. There is the scribe line, and the other punch mark is right in the center of that scribe line. So what we can do here is, this is the canvas, and then we want to calibrate it. So I know we measured that at 3 inches, so we're going to pick that point right there, and pick that point right there, and that right now is saying it's approximately over 1/8 of an inch, but we need that to be 3 inches. Boom! As you can see, it scaled that up significantly. All right. So now what we need to do is we need to start putting in some of these holes. We'll zoom in. I'll draw a hole to this perimeter, center the circle on that, and I'm going to go around, do that on all of these holes. And then what I want to do is check measurements between holes on CAD here, and then I'm going to measure approximately on the block itself, and I just want to make sure that we're pretty close. And then we're going to take this through from design to manufacture and create a CNC cut part. Okay, so in order to get drawing some holes here in Fusion, we need to create a sketch. So we're going to create a sketch on this plane. I like to make sure that when we're doing anything in Fusion and we're planning on going through CAM, computer-aided manufacturing, we want the y-axis up, the x-axis to the right, and z coming out at you, because that is the layout that the CNC table likes the most. Now you can go ahead and change settings like that in CAM to account for it, but I just like making sure we're starting at that now. Now I did leave the drawing off center to the axis because I think I'm going to try and find center of the crank, and then I can move to axis. So, and I'm also just not that worried about creating around your origin. It's always nice to try and draw around your origin if you can, because it's a really easy reference point, but in this scenario, I'm really not too concerned with it. But anyways, let's go ahead. Now that we have a sketch created, we're going to create a circle. All right, now what I've done is gone ahead and I measured an easy reference point and entered in the diameter that I measured on the crank, and that is to the kind of outside where this chamfer starts. So as you can tell right now, I'm not completely aligned, but I do have the correct diameter circle. So we're going to click on that. We are going to move it. And then we are pretty much going to line this up by eye. Okay, I want to go down. Let's try 0.5. Nope, minus 0.5, minus 0.05. Okay, that was a little too much. So 4, nope, 3. That still looks a little much. 2. That is pretty darn close. It's a little hard. I mean, this is where there's going to be a little bit of a lack of precision. But, I mean, we are talking 20 thou here. So I think I'm good with that for now. That is going to get us an origin point to the center of our crank, which is going to be important when we cut out the flywheel opening. Now I'm just going to go ahead, I'm not going to do it on camera because it's going to be a little fiddly, but I'm going to get all these holes laid out and then get the crank hole and draw the perimeter in, and I'll bring you back in and show you what this looks like when it's done. All it's going to be doing is, using these sketch tools to draw more circles and draw a perimeter line and stuff like that, and I'm pretty sure you can imagine what that's going to look like. So I'll just show you the finished product here, all right? So just hang on. Okay, so now you can see we have a mostly finished part. We filleted the edges real nicely there. So I'm going to go ahead. We don't really need this canvas anymore. As you can see, we laid out all the holes except that one, which I planned on. And let's turn that off. And now we can take this part and extrude it. I'm going to extrude it. Okay, we're going to select that surface and we're going to extrude it.
See, you can extrude it out. I'm just going to enter 0.375, which is our material thickness. And there you go. That is what our bell housing plate is going to look like. And I already went ahead and checked a lot of these circles, centers, and they're close enough. So I'm pretty happy with that. It's not an overly complicated part, but this is the first time taking an image and creating some with it. So with that now done, the next step is to take this into manufacture. All right, now with this in manufacturing, we're going to start a setup. Now I have pretty much everything set here as normal. We don't have to go ahead. We're doing cutting. Stock point, however, I do want to select as this bottom corner. It's just easier for me to lay the material on the machine. Stock, I don't need to go through and change anything. Program name or number, I'll change that at the end, so that's okay. Now we created a setup. Now it's time to go in the 2D profile, and this is where we're going to select our cutting parameters. However, I don't have a tool library made for the 3/8 material we're going to be using, so I need to go ahead and get that done, and then I will meet you back here. With our new tool selected, we can go through, and basically all I needed to do here was define the kerf width, and the cutting feed rate. And we're going to select that tool. It's going to change the presets to what I wanted. Geometry, we're going to use face contours, and we will select that face. And then we can go through for height. I'm not going to need to make too many adjustments here. Okay, I'm not going to make any changes here, and then we can go through to passes. We're going to leave the tolerance there, compensations to the left to account for the swirl on the cutter itself. In computer, that's all good. We're not going to need to do much there. This is a pretty easy part to cut. We're going to have no lead-in distance. We'll set that to 0. We don't need a lead out. Pierce clearance and lead in only. We don't need keep nozzle down because we have torch height control on this machine. And that's pretty much it. I don't really need to specify a lead in position, but let's start there. And it's going to start generating a cut path for us. So you can see it's working. Cool. That was quick because this is a pretty simple part. And you can see that it's going to show a cut path. And it's going to come through. It always cuts inner holes first and then does perimeter. And we can go through and run a simulation. There we go. All right, you get the idea there. So that is pretty much all we need to do. And then all we have to do is post it, which will create our G-code that we can send to the table. So I'm not gonna, well, I will post this now, but I'm gonna go ahead and post a version for 60 thou aluminum because I don't want to waste 3/8 mild steel. It's fairly expensive. I am gonna cut this out on a piece of scrap aluminum first, and then we'll check the fit. All right, I'm gonna get this done, and I'll show you the CNC cutting, and then let's test it out.
All right, well, I did get my table moved over. It was really in the way out on the floor, but I wanted to get it up and running. I had to move the 3,000-pound press brake, which wasn't very easy. The setup is not done yet. I want to make a nice fume hood for this. This plasma cutter I have is a little bit small. I'll probably wind up upgrading that someday in the future. So for now, the wiring is a mess. You know, this is a budget table. I mean, it wasn't cheap, but for the price you get, cable management wasn't very good on it, but it's all things I can upgrade. You know what? This gets me into it. If I upgrade tables later, I do. But for now, you know, the setup's not perfect, but I will be improving it in the days to come. So what I have here is actually one of the window cutouts from the Snowcat. 60 thou 5052 aluminum. It's not terribly expensive, so I'd rather cut the template, fit it to the machine, make sure I like it, and then I'm going to go ahead and cut the actual 3/8 plate out.
just so that I don't waste the money on that 3/8 because I only have enough, I think, for one. But let's go ahead. I'll get this set up and we'll do some cutting. Righty. That is our plate to mount the pump assembly to. I guess if you do this all the time, it's not cool, but I don't know. That's pretty awesome. So let's go see how it fits. All right, get the flywheel on. First things first. Okay. Sorry, it's not the easiest place to video here, but that is a turbo line. So there. Wrong way. That way. That way. There we go. Oh my goodness. Would you believe it? Lines up. Every hole can bolt on. Alrighty. I like it. I like it a lot. Oh yeah, we got that dowel pin in there still. That was messing us up. Alright, well I am happy enough with that. Let's go ahead, get some of that 3/8 plate on the table. Let's go cut this for real. Yeah. Cool. I know we're not going to get very far in this video, but this is a big step. This is an important step. It really is going to allow us to have a good starting point to build off of. Okay, I've got this big heavy piece of 3/8 on here. The only thing I had to do was go back and change the stock point to the upper left corner instead of the lower left, just because I can't push the material through that way, so I referenced the cutting on the far side. Everything's set up. I'm ready to click go. I do have enough plate here to do multiple. I didn't think this sheet was that big, but anyways, I don't want to waste it. Steel isn't that cheap. Let's click go and see what happens. Alright, so it didn't fully pierce through that hole, so I'm going to go ahead and add in some extra pierce delay to let it cut through and get that hole cut. I should be able to go back to that hole and recut it. Let's just make a few changes. Alright, I have gone ahead and increased the pierce delay from 1/2 second to 1 second, should get more time to go through. And I also lowered down the feed rate a little bit and added some pierce clearance, so we'll see what that does. All right, well that cut out pretty good. The one spot it didn't like, and I think it was running on one of these support ribs, was right along here. This machine is undersized for what I'm doing. I'm definitely gonna have to get a bigger cutter in the future here.
So when it hit the rib, it was just struggling and it lost its pierce, but then it picked it back up and kept going around. So that's okay. A little bit of cleanup there. The holes were pretty good. There's probably a small taper to them, again, because, you know, the torch is very undersized. But you know what? A heck of a lot better than me doing this by hand. So I'm gonna let this cool down. We'll get it out, clean it up, and fit it. All right, well, there's a little bit more dross than I would want to see, but see if I can get you in there. Cut is pretty nice. I mean, the cut itself is nice, and you know, the dross is just coming off, so you can just knock it right off. You can see where it didn't fully cut through here. Like I say, I think that was sitting on one of the ribs. That's what caused that, but I can clean that up. And there it is. I don't know, nothing wrong with that. Okay, let's go ahead, get some cleanup done, and see what the finished part looks like. All right, because I'm using a cutter that's a bit undersized, the outside edges cut pretty nice, but the holes cut with a bit of a taper, so I don't have a lot of them. I'm just gonna go ahead with a carbide burr on my die grinder, open them up a little bit. They're probably size big enough that work, but I might as well clean them up. All right, I think you can see this dowel here. All right, that's loose. So I just need to try and drive that out. Oh, there's no shoulder on the backside. All right, this is the dowel pin that we need to get out. I want to take it out from the backside here. I guess there'll be no luck with that. All right, let's go on to the next thing. All right. So this is not something you'd want to do if you were trying to reuse this dowel pin, but I am going to have to create my own nature of the beast. So I'm assuming it's maybe a little glued in, so throw a little heat on there. There we go. Where there's a will, there's a way. Getting this assembly mounted is really the main last thing I want to do before I start cladding in the hull as well. So getting this done, getting the mount down here and the pumps on, then the engine comes out, we split the cab off the frame, and we get into some serious welding. Okay, well there you have it. That is the engine plate. And then there'll be some angle that comes off here on either side, on all four corners. Then there'll be another plate with a large hole, and then a third plate that shoulders on the pumps. And when it's all aligned, I'll drill dowel it, probably weld this third plate to the second plate. And then the starter, this whole bracket assembly gives me a place to mount the starter in down here where it was originally mounted. And there we go. Wow. That's pretty cool. I really like that. All right. Well, I'm really happy with how that turned out. I know that wasn't a ton in this video, but I wanted to go pretty in depth, show you the process. So the next video, we'll actually build off this and get the whole pump assembly mounted. But for now, I think that's a good end point. It's getting later in the day for me, so I hope you enjoyed it. We'll see you next time.